Welcome to the lesson on Battery Management System Thermal Management Function. In this lesson, we will focus on one of the key functions of the BMS, thermal management. Let us look at our lesson objectives. By the end of this lesson, you will be able to identify the role of the BMS and the thermal management system, abbreviated as TMS, in maintaining optimal battery temperature. Next, you will be able to describe the steps involved in thermal regulation. Finally, you will be able to explain how lithium-ion battery characteristics influence the design and operation of an effective thermal management system. The BMS and thermal management system, TMS, are closely integrated to maintain the battery pack's temperature within a safe and efficient operating range. The BMS monitors the battery's temperature and other parameters, while the TMS actively regulates the temperature by activating cooling or heating systems as needed. The BMS is integrated with TMS to control the temperature of the battery pack, ensuring it operates within optimal temperature ranges. This may involve cooling systems, such as liquid cooling or air cooling, and temperature sensors integrated into the battery pack to provide real-time monitoring. TMS is a vital component ensuring safe, reliable, and efficient operation of lithium-ion battery packs. By actively controlling the battery's temperature, thermal management systems contribute significantly to the overall lifespan, performance, and safety of the battery. The steps involved in maintaining optimal battery temperature are temperature monitoring, data transmission, temperature assessment, and cooling activation. The BMS monitors the temperature of individual cells and the overall battery pack. The BMS then transmits the temperature data to the TMS via the Controller Area Network, CAN, bus, which is a common vehicle communication network. The TMS receives the temperature data from the CAN bus and analyzes it to determine if any part of the battery pack is overheating. If overheating is detected, the TMS triggers cooling mechanisms, for example, liquid cooling, air cooling, to reduce the temperature. The CAN bus serves as the communication channel between the BMS and the TMS, enabling them to exchange information and coordinate their actions for optimal battery temperature control. Excessive heat is detrimental to lithium-ion batteries, accelerating degradation and potentially leading to safety hazards. Thermal management systems are crucial to keep things cool. Imagine electricity like water flowing through a pipe. Cell components like electrodes have some resistance, like narrow spots in the pipe. This resistance makes it harder for electricity to flow freely, and some energy gets wasted as heat, like friction warming the pipe. Charging and discharging involve chemical reactions within the battery cell. These reactions are like tiny engines, and just like car engines, they generate some heat as a byproduct. This heat needs to be managed to prevent the battery from overheating. Several factors influence the design of a TMS. Lithium-ion batteries generate heat due to factors like internal resistance and chemical reactions. The TMS needs to be capable of handling this heat effectively. An ideal TMS should be efficient itself. While it removes heat from the battery, it shouldn't consume excessive energy that the vehicle could otherwise use. Balancing cooling needs with energy efficiency is crucial. Lithium-ion batteries are highly sensitive to temperature extremes. Excessive heat can accelerate degradation and safety risks, while cold temperatures can limit power output and reduce efficiency. The TMS needs to maintain the battery within a specific optimal temperature range. The TMS must function effectively across a wide range of ambient temperatures. It should be able to provide sufficient cooling in hot weather and adequate heating in cold weather to ensure consistent battery performance and lifespan. Compared to other battery chemistries, lithium-ion's higher heat generation and sensitivity to both hot and cold require a comprehensive TMS. This often includes cooling and heating capabilities to regulate the battery temperature across various operating conditions. Let us now look at the lesson summary on BMS thermal management function. The BMS and TMS work together to monitor and regulate battery temperature, ensuring safe and efficient operation. Thermal regulation involves coordinated steps where the BMS collects temperature data, communicates via the Controller Area Network bus, and the TMS activates cooling or heating systems as needed. The design of a thermal management system is influenced by the heat generation and temperature sensitivity of lithium-ion batteries, requiring a balance between performance and energy efficiency. Thank you.